Discoid lupus erythematosus, or DLE, is an autoimmune disease of the skin. Approximately 300,000 Americans suffer from discoid lupus, and according to the Lupus Foundation of America, more than 16,000 new cases are diagnosed in the U.S. each year. DLE is characterized by disc-shaped sores with inflammation, swelling, scaling, scarring, pigment discoloration, and even hair loss. There is no cure. The lesions from DLE most commonly appear in sun-exposed areas, predominantly on the face, chest, and scalp. The exact cause is unknown, but for many patients with DLE, UV rays from the sun or even fluorescent lights can trigger lesions. Damage from UV rays can kill keratinocytes, the predominant type of skin cell in the epidermis. The dead keratinocytes break apart and release particles that include proteins, DNA, and RNA, indicative of necrotic cell death. As part of the body's waste disposal process, the debris then migrates across the junction of the epidermis and deeper into the dermis. Once in the dermis, the cell debris, like foreign antigens, attach to the C-type lectin, or CLEC receptors, of dendritic Langerhans cells. At the same time, specific circulating antibodies latch onto other free-floating DNA and RNA particles, forming immune complexes which attach to the Fc receptors of Langerhans cells. Both actions initiate an immune response, which targets the healthy skin of the host by activating the spleen tyrosine kinase, or SYK, a master regulator inside the Langerhans cells. Once triggered, the cells secrete a variety of inflammatory cytokines. The release of these cytokines sparks the recruitment of numerous additional inflammatory cells. This results in an acute autoimmune attack, including an excessive proliferation of keratinocytes in the epidermis, which can cause scaling. The physical signs of the acute phase of DLE include swelling, scaling, and redness, manifested in disc-shaped lesions on the skin surface. Meanwhile, the released cytokines such as IL-2 and IL-23 bind to their cell surface receptors on T cells. This interaction sends an activation signal to the JAK enzymes located at the receptor's base. The JAK enzymes sustain specific growth and activation signals. Rapid cell proliferation ensues, amplifying the immune response. The newly activated T cells travel to the dermis of the host and proceed to attack and destroy tissue there. DLE's chronic phase ensues, characterized by scarring, a change in pigmentation, and potentially hair loss. The existing predominant therapies for the treatment of discoid lupus seek only to mitigate the pathway of one or another of the several types of mediators driving the autoimmune attack. Rigel's R333 is a potent topical SYK and JAK inhibitor. What that means is that R333 is designed to bind to both the SYK as well as the JAK enzymes in immune cells. The objective, to interrupt pivotal inflammatory cascade signals. Hence, we believe the action of R333 may result in a comprehensive response to DLE, with the potential to prevent or diminish both acute and chronic inflammation symptoms. In fact, R333 may well represent a highly effective treatment for DLE and is now in clinical trials.